So hi everyone. Good morning, guys. All of you. Today, in the last session, we completed the introduction part of PLSQ language. Okay, right. Now, in this PLSQ, one of the topic is cursor. Okay, and now we have basically cursors. Okay, so what is cursor? And these cursors, when we want to create, what is the use of cursor? And what is the advantage of cursors? Okay, and how many types of cursors we have here? So this kind of information we can see by using of the cursors here. Okay, now, so basically, guys, here cursor is nothing but it is called as it is a temporary memory. We call it is a temporary memory, or else we can say a private SQL area, a private SQL area, or else we can say it is a workspace. It is a workspace. Okay, cursor is nothing but is a temporary memory or a private SQL area, or it's a workspace we call. Okay, right. So these temporary memories are why we required. Why user want to create this temporary memory? What is the reason to create this temporary memory? Okay, so if you want to go to understand that point here, the first of all, in this cursor memory, that means this memory will be created by people, okay, and created by system. So that means the cursor memory allocations is going to be happen in two websites here. One is called as the explicit cursor. Second one is called as the implicit cursor. Implicit cursor. So that means this temporary memory, this temporary memory is going to be created by user. It's a one way of method, and created by system. So implicitly, this is another way of method. Okay, these are the two methods we have here. And explicit cursors, even though these memories are created by user, so that's what is called user defined cursor, because cursor is nothing but temporary memory, and this memory is created by user. This memory is created by user. That is one. Implicit cursors are nothing but predefined memory. Otherwise, the defined cursor of our memory we can call. Okay, right. So these are the two ways. Okay, so we have your cursors and cursor memories. One is user defined. One more is what now? Implicit cursor, system defined. Okay, so let me see, guys, here. First of all, user defined cursors or explicit cursors. Okay, why user want to create here? So what is the advantage of this? For what purpose the user is created? Okay, so that all the things we will be checked out. And Now I will take one small diagram guys here. So generally, whenever you want to fetch data from your table, generally what it was happening guys here. Suppose this is my Oracle database. Okay, that's it. So he is the user. Generally, we are the users. We are the users. So, and this is my Oracle database server. And in this Oracle database server, we have some table. Okay, we have some table, and data was having the database memory. So now, what generally, when we have not created explicit cursor memories, or when user is not created some temporary memories, then what happened? Whenever user is asking, okay, he was to fetch the data from your database. Okay, so whenever you want to fetch the data from database, what happened is here. Suppose he was writing one small query request here. So he was asked select star from some table, okay, or some condition where EID is equal to, okay, some condition was given. Okay, this is our condition request. So when this query request user sending to database server, this request will go to directly your database. Okay, so user request will directly go to database, and whatever the query request you was sending to database server, okay, as per the query request, your database is going to be written that particular 101 employee data to your user. Okay, so now this request will go to databases, and databases are going to be searching the EMP table, because in database there are so many tables so many tables are there. In so many tables, okay, which table you wanted, EMP table you want. So it was searching EMP table. After searching EMP table, in this table, specific row, 101 row, we are getting that. Okay, that is what it was. After fetching that, the fetching information, okay, so again, it will be sent back to user application or user. Okay, this is what. So the response is sending to user application. So this will be happening, okay, for every time. So whenever user is sending one query request, the request will go to database, and database is going to be processing the request and finding the data. After finding the data will send back to user application as a response. Okay. So this is generally in every database when user interacting through database servers or databases. This is going to be happening, guys. This is going to be happening. But carefully observe, guys, here. Okay. So here, first time I'm sending select star from EMP where EID is equals to 101. So 101 record is retrieval. In the second time, user sending one more query request. Now later, okay, he was sending, okay, suppose he was sending 105, he was sending now 105. Then what happened? Again, the request is a new request. So now this time, previously 101 I wanted. Now this time the user wanted 105. Again, what happened, guys? Here, again this request will go to database. Again, database is going to be processing your request and finding your data, and the data sent back to user application. Okay. Suppose user is asking some more. So that means whenever user is fetching the data from your table, okay, now for every query or for every query request will go to database. Database will take that your request, processing, sending response to user. This is going to be happen for each and every time. So now whenever, okay, for every time this going to be happen means automatically what it was happening as here. For every user request will go to database, and database will take the responsibility processing, sending response. This is a common, okay, work. It is going to be happen in between user and databases. But in the cases, what it was happening is here, for every request will go to database means automatically database burden is increases. Database burden is increases. So when database burden increase, automatically performance wise, it will be degraded your performance. Yes or no, guys? Okay. For every request is going to be directly data. Okay, suppose there are 100 users are there. 100 users are sending 100 query requests. Then those 100 query requests will go to database server. Then what happens is here, the database burden will increase as here. Okay, now. So whenever database burden is increased, automatically it will be affected on the performance of database. Okay, so that means we are getting more load on your database, automatically database pressure increase. Then automatically performance wise it will be degraded. So this is generally was going to be happen. Okay, so to overcome the burden on database and to overcome the pressure on database and give, okay, and providing the performances, good performance. Okay, so then what user will go to do generally in applications, what they will do. So instead of going to this mechanism, this is a default, normally it was happen. Okay, what they will do, guys, here. Okay, why is every user request I have to send it to data server? Why database server will get a pressure, and when you get a pressure, automatic performance is degraded. So to overcome this problem and improve the performance of databases, improve the performance of databases. Okay, so what the people will do here? Observe. Same as this is your Oracle database server. Okay, now this is my database. So user, okay, the first problem is what now? Burden and performance will be degraded because of every user request will go to database server. Okay, by this reason, the performance wise it will be degraded your database. Okay, fine. So to avoid this problem, guys, what the users will do it here, they will be created one temporary memory. They will be created one temporary memory. Okay. So here there is no temporary memory. So directly request will go to database, and from database directly we are sending response to user application. But in that cases, problem is be identified. It's a more burden because of reason every request will go to database, and performance wise it's a very slow performance will be given. Okay. So now the user, to avoid that problem, what the user will do here, they will be created one temporary memory is created. But whenever they want to create their own memory, so they need to follow some mechanism. That means they need to write some code. So here the user want to create his own memory location. So you need to follow the 4 steps mechanism, guys. Okay, you need to follow the 4 steps mechanism. You need to follow. The first step is what, sir? What is my first step? The first step. Okay, we need to declare one cursor variable. I need to declare. So this is my step 1, guys. Yeah. What user has to declare? Okay, cursor memory. So cursor C1 is along with the declaration of cursor. So here the user is sending one query request from processing. Select star from EMP table. Okay, or else where condition, whatever it is. Okay, so 105. So one query request also they will be sent along with the cursor variable declaration. So what is my cursor variable, guys? Here C1. So C1 is my cursor variable. We declared here. And we're passing select star from EMP where some conditions. So this is one query request we sent. So whenever the user is going to be created this, okay, there was writing this code. Internally, what it was happening, sir, means, okay, on the name of C1, on the name of C1, okay, the memory will be allocated here. Okay, so that means on the name of, whenever you declare your cursor variable, on the name of cursor variable, some memory is allocated. And this memory is called as a cursor memory. And this memory name is C1, cursor memory. But this memory is going to be created by who? User. By declaration of cursor variable. So whenever user is declared cursor variable, for that cursor variable purpose, it was allocating some memory. And that memory is called as a cursor memory or temporary memory or a workspace, okay, or as a SQL private area also we can say. So okay, memory is going to be created. But a very important thing is what now? Here only declaration and declaration purpose, it was allocating some memory for your variable C1. That was happening. But whatever the select query request I written here, this select query request will not executed now. Okay, the select query request will not be executed now. Then where it will be executed? When it will be executed, your select query request means in the second step. What is my second step here? Now I need to, Then user after declaration of your memory, then my second step is what now? Okay, he want to open my cursor connectivity. So step number 2, what is now? Open. So you want to open. So open C1. So whenever the cursor memory, the cursor connectivity, the memory connection is going to be open, then immediately whatever this query request is there, guys, here, whatever this query request is there, select query request. This select query request will be executed. Okay. So once cursor connection open, for example, I'm open this cursor memory connection. Okay, I open. So once I open cursor memory connectivity successfully, then whatever the query we written now, select a star from EMP where EID, this query request is going to be executed. That means now this query request will go to database now. Okay. Now this query request will go to database now. Okay. This query request will go to database now. And whatever the query we written now, based on the query request, what your database will do, the data is first transferring to your cursor memory. Transferring to your cursor memory. That means the data is going to be low. Okay, the data loading into cursor C1. Cursor memory loading into cursor C1. Okay, fine. Okay. C1. So that raw data, now it was come to your cursor memory. Now the raw data, it comes to your cursor memory. Understand now? So once it was coming to your cursor, loading into cursor, what happened guys here? The next attempt, when user wanted, okay, so the data, when user wanted the data, then what happened? Whatever user is going to be fetching the data, the fetching operation, it doesn't go to the fetching request. The fetching request, it doesn't go to database here. The fetching request, okay, will go to directly cursor memory. And from there, I want to take my necessary data. Okay, so that is we called as a step number 3. That is called as a step number 3. So what is the step number 3? After your required data is successfully loading into cursor memory, then in step number 3, what you want to do, you need to now user want to fetching the data from memory C1 memory. Okay, fetching the data from C1 memory. Okay, now. So and after fetching the data from C1 memory, the data you want to bring under some variables, pulling into some variables. Okay, fetching data from cursor memory, pulling into some variables. So once data successfully fetched from cursor and storing into variable, okay, then what the next user has to do? What next user has to do? The user has to go and close your cursor memory connectivity. Okay. Then after successfully your necessary data be taken from cursor memory, then I need to close my schema. Then what happened? Whatever this, okay, we open here, this cursor memory connection will be closed now. Now it will be closed. Okay, now it will be closed. Okay, so these are the guys here. What it was happened now. Now user request from next onward, that means from later onwards. What happened? Now user is going to be interacting with your cursor. He was not interacting with the databases. And every user fetching request will go to cursor memory. But the fetching request will not go to databases. So that means what happened? The number of user requests will be reduces on your database. Okay, first time only your query request, this query request will go to first time only your database server. Okay, first time this request will go. So in this first time, what are the query request and what are the query return will be go to that request will go to database. From the second time onwards, when user needed to fetch the data, fetching means taking data. So whenever user need to fetch the data from the second time onwards, from the second time onwards, what happened guys here? The request will not go to database. But every fetching request will go to cursor memory, and from here itself, data will be fetching. This is not only one record. Suppose if I'm going to say, I'm going to pass in here, for example, okay, suppose my request will be not where condition. Was not where condition now, for example. Okay, so now he was sending select a star from EMP. Select a star from EMP. When he was sending select a star from EMP, so what happened guys, your entire the table data will come to you. The same as this, what happened here, your entire table or table data is going to be loading under cursor memory. Not only single row, even though group of rows also same things happen. Now he was asking select a star from EMP. In which way the request was sending here. So based on that particular data, your data is sending to your cursor memory. So now he was asking entire table select a star from EMP. Then what happened? Entire table will be loading or sending to cursor memory. And later on, user whatever he want data, the data he can fetch from cursor memory. So that means again, the next time the fetching request will not go to databases. Okay, for every fetching of your necessary data, the user will access from the cursor memory. So in that cases, what happened guys here, now you can observe carefully. So number of user requests will be reduces on your database. Okay. So whenever the number of user requests will be reduces on database, automatically burden is also reduced. Because when the burden is increased, the number of user requests will be increases, then your database burden also increases. Okay, but your number of user requests will be reduces by user. Okay, the number of user requests will not go to database only first time. First time your select query request only going to database. From later onwards, whatever the fetching request we are sending, that every fetching request we are going to be taking, we are sending to cursor, and from the cursor we are taking out data. So that means what happened? So here database request will be reduces. Yes, sir. So request will be reduces. So when it is reduces, automatically burden also reduces. When burden reduces, then your database performance will be good for us. Okay. So this is what we call as guys here explicit cursors. Okay, user why they created explicit memories. Here cursor is nothing but temporary memory. And here one more very important thing. After fetching your data from your cursor, whatever the necessary data you're fetching, you have to fetch. And later, when you was closing your cursor connectivity, what it was happening guys here, your cursor memory automatically destroyed. The cursor memory automatically destroyed. Okay, because of reason, we are closing our cursor connectivity. So whenever we close our cursor connection, automatically the memory also released by your server. The release means limited memory also vanish. memory is also vanished by data reserve. Okay, that's why cursors are not a temporary or not a permanent memories. Cursors are not a permanent memories. That's why it is called as what not temporary memories required. So now this is what the explicit cursors, why the users are created. Okay, right. So these are the creation of explicit cursors. And now simply we are saying that finally we can take as your these cursors are created by user for holding holding okay multiple rows. Okay, holding multiple rows in cursor memory, and later and later and later user can access the rows. User can access the rows. Okay, rows one by one manner. Here, so this memory is created by user for holding your multiple rows, data. And after holding your multiple rows in cursor memory, later user can access the rows. User can access the rows in one by one manner. And a very important point is what now? Whenever user want to fetching the data from cursor, suppose your cursor EMP table is there. Suppose your EMP table is having 14 rows. EMP table is having 14 rows. But whenever you want to fetch the data from EMP table in cursor memory, so I can't fetch 14 rows at a time. I can't fetch 14 rows at a time. So how that 14 rows I'm fetching means in one by one manner. That means for every fetching of request, we are accessing, we are retrieving only single. Every fetching of a row or every fetching of your data, only one row data we can fetch at a time. But you can't fetch multiple rows at a time. But multiple rows I can hold, I can store, but I can access only one row at a time. Okay, right? So this is explicit cursor, the nature of, okay. Now, but these explicit cursors, if you want to create, okay, what is that? To create an explicit, cursors, create an explicit cursor, okay, we should, follow, okay, following four steps, right? We should follow the following four steps mechanism. Four steps mechanism. Okay, what is that? Here I already said you. Step one. First I need to declare my cursor variable. This is my first step here to declare my cursor variable. Okay, so how you can declare it? Means we have some syntax here, the formula how to declare cursor variable. So now here I'm going to use declare cursor name, cursor variable name, and is. Now I want to write here my select query. Okay, so the select query as your wish, based on your requirement, you can write your select query in any manner. Okay, so by using where condition, group by condition, having condition, yes or no, order by condition, whatever you can write your select query. So whatever you written the condition in the select query, based on the select query conditional statement, your data will be loading into cursor memory. Okay, now, so how your select query you written based on your select query request only, your database server, what it will do, the data will loading into cursor variable memory. Suppose select a star from EMP table where job is equals to clerk. So then what happened in your EMP table? How many clerks are there? That all clerks information is going to be sending to cursor memory. Sending to cursor memory. And now that was taken by user. Suppose select a star from EMP where department number is equals to 20. Then how many employees or how many rows are there? Department number 20 rows. That all rows are going to be selected and sending to cursor memory. So that means whatever the select query request are you written, based on the request only, your data will be sending to cursor memory. Okay, that is what. So that's why select query is very important for us. Second one is called what open cursor item. After declaration, open. So in this, we have a syntax that's here. How to open means we are writing open and passing here cursor name. Next, step number 3. After that, what we want to do, fetching rows or rows data from memory, cursor memory. Now, from the next time onward, what I said, whatever you need to fetch the data, the fetching data is not from database memory. Fetching data is not from database memory. Fetching data from your cursor memory, because my database interaction was not there. User is not going to be interacting with the database. So over first time only I'm interacting, but later I don't want to interact with your database. Okay, then later I'm interacting with my cursor only. Okay, now right. So now how you want to fetch? So you have some formula. So fetch. Where are you fetching from? You're fetching from cursor. So what is your cursor name? The cursor name and every fetching of data. So every fetching of a row data, every fetching of a row data, what it was there, I want to store into variables. I want to store into variables. Okay, every fetching of row data, we should be stored into variables. Okay, now that is what. Later, step number 4. After your required necessary data was fetching from your cursor memory location, then I need to close my cursor. So what is the syntax for closing cursor? Simply close. I have to give cursor name. Okay, now so these are the 4 steps mechanism, guys. These are the 4 steps mechanism. Okay, cursors. What it will do, guys, it can be created by user. That means user creation. These all are. That's why we are writing some code. The 4-line statement code we are writing for user defined memories purpose. Okay, right. And these are the 4 steps: declaration, open, fetch, and close. Okay, right. So after that, after memory allocation, memory creation, data loading into memory. Okay, now, and after I need to fetch my data from cursor memory. But before you want to fetch your data from cursor memory, first of all, we need to check in this cursor memory or not. Data is there or not. So that I need to check it here. So how we can check? Because before user want to fetch the data from cursor memory, first we have to check now whether data is there or not there. First we have to check. If data is there, I can fetch. If data is not there in the cursor memory, then we cannot fetch anything because my cursor is empty. My cursor memory is empty. So if it is empty, there is no data under cursor, then how can you fetching the data? Yes or no? So we can't fetch the data. That's why what we want to do before I need to fetch data from cursor memory location. First of all, in the cursor memory, so data is available or not, we need to check. Then how to checking, sir? Means there are some attributes are there. So they're called as the attributes of an explicit cursor. An explicit cursor. Okay, right. So explicit cursors. Okay. Now you can see what kind of attributes it was having. Means there are total the 4 attributes we have here. And these attributes are, this is what now these attributes are used to, okay, are used to show or to take data is available. Okay, data is available in cursor or not. So that I need to set here cursor or not. Okay, right. So now in the first one, percentile is open attribute. So percentile is open attribute. So what it was going to do means it was it written it written true when it was written true when cursor connection and cursor connection successfully open. Okay. So whenever cursor connection successfully open, then is open attribute returns true. Otherwise returns false. Otherwise returns false. Okay, right. Come to second attribute. Second attribute is what now guys here percentile. Okay, found attribute is there. So percentile found attribute when it returns true. It returns true. Okay, when cursor is having or contain, cursor is having data. So in your cursor memory, suppose the data is there, then found at the data is there means data is found. So cursor is having data. That means data is found. Then it returns true. It returns true when cursor is having data. Okay, na? Otherwise return false. Otherwise return false. That's another attribute. Third one is called as a percentile not found attribute. Percentile not found attribute. So percentile not found attribute is the quite opposite of your found attribute. That means it returns when cursor is not having data. Okay, if cursor is not having data, that means data is not found. Data is not found in my cursor memory. Okay, data is not found in my cursor memory. Then it returns true. Okay, because it is a not found attribute. Otherwise, false. And the next one is called as a fourth one, percentile row count. The percentile row count attribute, what it was telling means it returns, okay, number of statements are executed. Number of statements are executed. Okay, that will be written here. That means here indirectly, that means here simply we can say, okay, how many number of rows are affected? Number of rows are, okay, how many number of rows are affected? Okay, how many number of rows are affected? That will be written by row count. So these are the 4 attributes guys here. The 4 attributes. Okay, so what it was telling us here. So first is open attribute. This attribute will be written when cursor connection successfully open. If connection is not open, it returns false. So false means showing some error. Okay, now, right. Found attribute, it returns true when cursor is having data. Otherwise, it returns false. Not found attribute, it returns true when cursor is not having the data. Okay, otherwise it returns false. Row count, it returns number of fetch statements are executed. That means how many number of rows are affected. Okay, in your table. So that will be written. So these are guys here. The cursor or explicit cursor attributes report. Okay, now right. So this is complete information about the explicit cursors. And let me see some examples on this, and you will get some idea. First example, guys, here. Write a cursor program. Okay, write a cursor program. Write a cursor program. To fetch a single row. Okay, fetch a single row from EMP table. Okay, now let me see one basic example of what is my example. Write a cursor program. Write a cursor program to fetch a single row from EMP table. So now I need to fetching one small, okay, one single row. I'm saying here, not multiple rows. I'm saying single row from EMP table. Okay, so fine. Let me come back here, guys, to open your database now. Open with your database. Okay, so what I have to do? Server underscore output. Server output is on. Yes or no? This is very important for us. And next one is set verify. Verify should be make it off because the old and new bind variable statements we are hiding. Okay, these are the common things to every time you have to set these. Okay, and after that I need to call table, so EMP table. This is our working table, guys here. So EMP. So what is our requirement here? From this table, I need to fetch a single row data. I need to fetch a single row data. Okay, so now I'm going to write in my cursor declaration. So declare cursor C1 is the selected star. You can use a star also, no problem. But if I move a star, means these all columns data we are going to be fetching. Okay, right, that's the difference. Otherwise, simply I will take e-name comma salary. Employee name comma salary I'm fetching from EMP table. So here columns data I'm fetching from EMP table. Okay, so this request what happened? We are retrieval e-name column data, salary column data from EMP table. EMP table means from database. From EMP table means database and storing into a cursor memory. So you are very in the question in the statement only can understand easily. So you know simply we can understand. What is the here? Are you select command? Retrieval. Select command is what retrieval. So retrieving e-name column data, salary column data from which table, guys, here? From EMP table. And those columns data, whatever you retrieved from EMP table, those columns data I'm storing under one temporary memory. The temporary memory is called as a C1. Understanding that? So retrieval, your necessary data from EMP table is nothing but database table. Okay, necessary data you are retrievable from database, and that data are you keeping, are you storing under cursor memory. Okay, now this is the meaning of this. Okay, okay. So now here two columns are selected now. So that means these two columns data I am retrieving. So these two columns data we are retrieving from database and storing under database memory. Okay, and from there we are fetching. But fetching data, what I said, compulsory we should store under variables. Yes or no? Can you remember the syntax here? So what I'm saying here, every fitting of row data, compulsory fitting of row data, whatever the raw data are you fetching from your cursor memory, the raw data I want to store into variables. Okay, so that's why in this program also I need to declare the variables. But how many variables I want to declare, sir? This kind of doubt is coming to you. The number of variable declarations are depending on your number of selected columns. Carefully observe. Carefully observe. What I'm telling guys here, your number of declaration of variables. That is how many number of variables I want to declare, sir. So how can you know? How can you know how many number of variables we need to declare? So that will be depending on your number of selected columns in select query. So in select query, how many columns are you selected? That many variables are declared. For example, if you selected one column, one variable, two columns, two variables, five columns, five variables, 10 columns, 10 variables. So like it will be defined. Okay, so now here in this example, I selected only two columns. So that is two variables I'm declaring. Variable ename purpose 1, variable salary purpose 1. Okay, and it's going to be happen. Later we are entering into execution statement. Okay, only. Okay, so two variables we declare. Now execution block start with beginning statement. Okay, now beginning statement. Okay, fine. Now what happened after? Okay, in this, what I need to do? Open now. My memory connection is open. When the memory connection is open, when your memory connection is open, what I said, this query internally executed. Okay, that means until unless your cursor connection is not open, until unless your cursor connection is not open, then your select query will not executed. The point is very clear now. What I'm saying here, until unless we are not open cursor connection, then your select query will not executed. Okay. So whenever we open cursor connection, then only your select query will be executed. Otherwise, never. So that's why we must and should be open. So open C1. When we open, immediately this query is executed. And whatever the columns data I'm asking here, this two columns data retrievable from EMP table and immediately storing under C1 memory. Okay, once open, query executed, and after executing the query data, taking from database memory and storing under cursor memory. Okay, now? Okay, fine, sir. After that, once data is comes under, once your data is successfully comes under my cursor memory location, then I need to fetch the C1. Okay, taking from where C1 and storing into here what variable. What is my variable? V underscore ename, comma V underscore salary. Yes. Okay, very simple. So fetching data from C1 and the data storing into variables. Okay, fine. It was happened. And whatever the data we are storing under variables. So these variables I need to print on my screen. For printing purposes statement dbms underscore output dot underscore line of v underscore ename concatenation comma concatenation v underscore salary. Same as it's the variables are printed. After printing data on the screen successfully, we are printing and printing. Then I need to close my cursor connection. Okay, after closing, end your begin statement. Okay, so your begin statement is ended. Okay, now here open cursor is closed. Then I have to execute. Now you can see what is my first row? Okay, it's an 800. Can you tell me in my table? Can you tell me in my table what is my first row here? Okay, and his name is Smith and salary 800. So it means here there are 14 rows are there, but out of 14 rows, we are fetching first single row only. We are fetching the first single row only. We are fetching. Okay, now right. So this is simple program. This is one simple program here. Okay. So now here very important thing is what now? Observe. Here, how many fetch statements I written guys here? Come on guys, tell me. How many fetch statements I used in this program? Only one fetch statement we use. So we used only one fetch statement. That's why only one row data we are getting. Understand my point now? Because I said whenever you want to fetch rows from cursor, how we are fetching guys here? One by one row fetching. That means every fetch statement, a single row data only we are fetching from cursor memory. So that's why I'm using one fetch statement. So first row is got it. Okay now. But in my table, carefully observe, in my table, do you have only one single row or you have a 14 rows? How many rows are there in your table? Only one row or 14 rows? 14 rows. So 14 rows, if I want to fetch means, a fetch statement, how many times I need to write them? If I want to fetch 14, then how many times this fetch statement I want to write? 14 times do you need to write? Okay. For example, let you see, for example, same program for your understanding. Either fetch statement is fetching only one record or not. First fetch, second fetch, third fetch, fourth, and five. So total five fetch statements written and books and it end. Now tell me, here how many fetch statements I written? Total 5 times I written. First time, one row. Another fetch, one row. Another fetch, one row. Another fetch, one row. Another fetch, one row. So 5 times I written means how many rows are fetching now? Come on guys, how many rows are fetching now? 5 rows are fetching. Let you see. Let you see 5 rows are fetching or not. Yes. First row Smith, second row Allen, third row Ward, fourth row Jones, and fifth row Martin. So now it is confirmed now. It is confirmed now. Fetch statement is fetching only one record. Is it confirmed? But guys, tell me, if I have 100 rows out there in my table, are you writing 100 times your fetch statement? No. So then how to fetch multiple rows? The question is how to fetch multiple rows. Okay, now, so that the question is coming to you. How to fetch multiple rows? Because if you want to fetch a single row, only one fetch statement, then how we can fetch multiple rows here? Then what we want to do it. Okay, now, so that the multiple rows fetching mechanism we will discuss in tomorrow's session, guys. Okay, so tomorrow we will go for the how to fetch multiple rows from your cursor memory. Okay, instead of writing number of fetch statements, okay, how we can fetch multiple rows from your cursor. So that we will see in tomorrow's session. Okay, right, yes. Thank you. Thank you so